Hi, hello everyone. A big hi to all my बच्चा लोग कैसे हैं सब हाँ How are you all doing? And how was your weekend? I think you have utilized the weekend in the best way possible so that you can make an amazing preparation for the term one examination. हाँ रहा है ना? So I think you all have made the best preparations in this last weekend. And yes, I really want to know everything from your own words, है ना? Because I don't want to keep on making guesses. So tell me, everyone, how was the weekend and how was the day going and how was the studies? Everyone, jaldi. Nidhi, hi, Ferry, सुमित सर की गैंगस्टर अरे बाप रे गैंगस्टर भी आ गया तो डरावना की बात है हाय स्टीव सो हाय ज्ञानी बाबा हाय सिंपल गर्ल अ बिग हाय टू एवरीवन इन द क्लासरूम सो कैसे हाउ यू ऑल डूइंग ओके जल्दी एवरीवन टेल मी हाउ यू ऑल डूइंग सब बढ़िया आर यू ऑल हैप्पी स्माइल ऑन योर फेसेस I don't want to hear the word scared, sir. Term one examination is going to come. अरे exams आएगा जाएगा. What you have to do? Just keep on preparing in the best way possible. ठीक है? Go and write the exam. फोड़ ले. Oh, कोई बात नहीं सुदीप. Please take care of your health. You are going to be totally okay soon. ठीक है? I know that. मेरा बच्चा है ना तू. ठीक है? So तू ऐसे हो जाएगा. तू you'll be so healthy soon. ठीक है? So I'll pray for you. May God bless you to give back your health as soon as possible. So yes, so thank you so much everyone. You all know what is so special about today's class. What's so special? Yes, in today's session, we are going to start the new crash course, the new topic in today's crash course. Which chapter? Magnetism and Matter. This is the first part. Tomorrow we'll be ending up this particular chapter. Hai na? So yes, let's see what all are the formulas, definitions, and lot many multiple choice questions we have for today's session. And at 11:10 p.m., what do we have? Menti quiz will also be there. Let's see who's going to be the winner of today's session. Okay? So yes, whoever is seeing me for the very first time, this is Ameer, your physics educator at Unacademy. And those who love me more, what do you all call me? Ameer Bhaiya, hai na? Yes. Now a bit of introduction about myself. I hope you all can see. I'm a beta graduate from an IT Calicut in mechanical engineering. I've been teaching for more than 3.5 years for JEE, NEET and board student, and I'm also from Kerala, chalo. So मुझे हिंदी तो उतना नहीं आता है, ठीक है? So माफ कर दीजिए. So we'll be doing the entire explanation, मतलब conceptual explanation in English. The rest of the things, okay, थोड़ा थोड़ा हिंदी में add, okay, just like adding flavors to food, and I'll be doing it. So as you can see, so tomorrow we have the part 2 of Magnetism and Matter. देख लें, what do we have on Wednesday? Super important formulas नहीं, okay? So it is a super important MCQ का Menti quiz हो जाएगा, okay? Which chapter? Electromagnetic induction chapter का, okay? So yes. Then what do we have? Mega Menti quiz on which day? On Thursday at 10 p.m. Mega Menti quiz matlab all the chapters that is going to come for term one examination, hai na? From all those chapter questions are being chosen and we are doing the Menti quiz. So you'll be having a complete idea. Matlab if question pop-ups all of a sudden, how you have to face it, okay? How to tackle those emotion, matlab if you are having pressure or not, so we can do that. So it's going to be so much amazing. So expecting every one of you on Friday. We have the sample paper discussion and analysis. Okay, on Friday at say 10 p.m. So make sure that you attend to it so that you will get an idea how the sample paper is going to come for the term one examination. Okay. But chalo, don't you have so many favorite teachers with an Academy class 11th and 12th YouTube channel, hai na? So you don't want to miss any of the live classes. Matlab, you need to get alerts and notifications on time. Kaise? Be a part of the Telegram channel. Link idhar de diya. So whatever notifications and alerts, okay, related to the Academy class 11th and 12th YouTube channel, everything will be available in this हमारा Telegram channel पे, ठीक है? Link ऐसे ही दे दिया description also. If you go, you will find the same link. Okay, click करके you can be a part of it. देख ले, ये Bugs Bounty क्या है? Bugs Bounty, it's an amazing program designed by Unacademy so that all the bacha logs, all the students will get as many prizes as possible. What do you have to do? Go to the description, there you'll find a form. Fill the form if you're finding any inappropriate content in the video uploaded by Unacademy. If it's valid, ऐसे आ जाएगा prize आपके घर पे. So anyone new here in the classroom who doesn't know about this Emerge program? Okay, so let me tell you, this is a super amazing program which will help you to ace the term one examination. Because you know, term one examination is going to be with multiple choice questions and search and recent type questions. मतलब some kind of questions which you are not so much familiar. So you have to get familiarized with it. You should be doing enough practice, right? That's all about the Emerge program. So in Emerge program, it will be the live mock test which will be happening for all the subject, matlab maths, biophysics and chemistry on these days and happening every week. Time 5 to 6:30 on the respective dates. You can find the respective subjects, and if you want to enroll for free, what you have to remember, can you remember this 5 letters? The code is AMB10. Use this, be a part of an Emerge program completely for free. If you get good ranks, you'll be published in all the social media handles and also obviously you'll become famous bhi ho jayega thoda. Along with studies, okay, thoda aur bhi mil jaye aapko. Very good. Now, but chalo, can you all do a small favor? Okay, not just to me, to all your friends also. Tell all your friends, jaldi share karke bol de that magnetism and matter, which is a very important topic for term 1 examination, is going to get started. Okay, everyone, jaldi se jaldi join kar le. Okay, tell to everyone, all your friends, and ask them to join as soon as possible. Okay, can you share the class? ठीक है? Can you all? Sanchana, we have. Then सुमित सर की गैंगस्टर है, तमन्ना है, then कौन कौन है, सब है ना. So जल्दी जल्दी शेयर करके बोल दीजिए सबको. Okay, then in the meanwhile, whoever is new in this platform, मतलब whoever is attending an academy platform for the very first time, I'll just give a brief introduction about a subscription platform. What is so special about the subscription platform of an academy? But chalo, obviously we are talking through YouTube, right? Every information is nowadays available in YouTube, and all the lectures from all the teachers are available. But you know that while you try to learn from YouTube, it's a very good thing. I also do appreciate, but it is a bit time consuming. Matlab, the information is a bit scattered here and there. So finding out each and every information, it will be a bit time consuming. So if you don't want to spend time there for arranging all the information, instead you want to use that particular time for studies, the first thing is you can be a part of this Unacademy platform. Okay, because in the platform we all educators will be teaching with a proper schedule targeting board, JE and NEET examination, and at the same time we'll make sure that all the topics are being covered in a proper order so that you can keep track of whatever topics are being covered in the classroom. So क्या हो जाएगा, everything will be in a proper order and you can learn at any point of time without any confusions. So you'll slowly fall in love with studies. You'll start spending more and more time. Obviously, you'll start working in a very smart way. And at last, yes, you can see a very huge progress in your studies. That's one thing I can promise you, Chalu. Then, top educators of the country who's having a very good experience will be there to teach you. They'll be knowing the exam pattern, don't you think? They'll be knowing what all MCQs you should be practicing so that you'll get a good mark. You just want to follow them. Obviously, you will be ending up in the colleges which you're dreaming about. Study materials, practice tests, and live test series will make you super confident. And now, chalo, will bring out the best from every one of you. And as we are almost at the month end, I think, matlab academic year end, 6 month subscription is more than enough. It will cost you 1,667. Okay, and if you want again 10% of discount from that, use karle code AMB10, get 10% of discount and as many offers as possible. ठीक है, देखिए, last thing. Some of you like, we want all the features of Plus subscription. We want more features. Those people should be going for Iconic. Iconic है ना, you'll be given a personal mentor. मतलब a friendly person or a brother person to you. So he'll be telling you how to study. And when you feel low, he'll be telling you don't have to worry. Okay, bacha, okay, just start learning this particular topic. Obviously, you'll improve. He'll be there for all your academic activities. So you'll feel, okay, or you can start learning a bit relaxed manner. ठीक है, live doubt solving classes will be there, weekly reports will be given to you in Iconic subscription. If you're going for 6 months, it will cost you 2,833 per month. And I know that everyone will be love to have a discount. ये code use कर ले, it's AMB10 and get 10% of discount and as many offers as possible while you make the subscription. ठीक है? And don't think that everything is paid here. So special class is going to happen on 17th November at 4:30 p.m. which is this Wednesday. What is it? Complete chapter MCQ series. It will be a quiz session where you all can go through the questions from throughout the chapters of term 1 examination. So it's a very good opportunity to make a very good revision. Be a part of it. It's completely free. ठीक है? And the unlock code is AMB test for this. Okay, yeah. Sudeep is not well, so Sudeep, don't worry, you'll be soon. Okay, you're going to be healthy so soon, है ना? और क्या? So obviously you are one of my legends, है ना? Legends are super strong. आप ऐसे ही आ जाएगा. So tell me, are you all ready, बच्चा लोग? Are you all ready for the session to get started? And be so much attentive in the classroom, बच्चा लोग, क्योंकि है ना? Because Menti quiz is there at the end of the session. You all know that, isn't it? So if you want to be a top in the Menti, so be so much attentive in the class. So much, matlab so much. Very good, Sudeep. That's the spirit. That's the spirit of my legends. And that's why you all have the name legends. So have you all shared the class to all your friends? Asked everyone to join as soon as possible? Kar diya? Yashwant, Shreya, Myara, Sanjana with full josh. Arre baap re, Myara is like, let's start. Anna with full, okay, full attention. ठीक है, देख ले. So we'll be going just like how the flow of topics is in your NCERT book. So if you want to keep NCERT book open next to you, you can do that, right? So that you can compare and learn. Okay, so new chapter, magnetism and matter, right? In this particular chapter, we are going to talk about magnetism and how it is related to different materials. Okay, starting with the basic concept. What is magnetic field lines? In the earlier chapter also, I think I have mentioned you. So those who are absent there or those who didn't attend that particular session, you can make use of the session to learn what is magnetic field lines and its properties. सबको पता है what is magnetic field, है ना? So representing the magnetic field in a graphical way or with the help of lines, we call it as magnetic field lines. What is it? Representing, I'll write it down here. You can also, this is very important. Definitions, this is something so much important definition. So it will be better if you write it. Representing magnetic field with the help of lines. Okay, वो होता है हमारा magnetic field lines. There are certain properties, okay, that you have to by heart it, so that you can draw magnetic field lines for any given magnetic configuration. देख, obviously for a magnet we have a north pole and a south pole, isn't it? So magnetic field lines, everyone start writing. It starts from the north pole. Outside the magnet, it will move toward the south pole outside, and inside the magnet, is it going to stop there? No. Inside the magnet, field lines will be moving from south to north, making it as one closed loop. First property, starts from north, move towards south outside the magnet. Inside it moves from south to north, making it as one closed loop. Very important. लिख लिया सबने? Everyone, the very first point. Okay. Now, remaining points are same as electric field lines. How will you find direction of magnetic field at a point? The tangent drawn at the field line gives the direction of magnetic field. मतलब ये line है ना? I want to find out the magnetic field at this specific point, let's say. What do you have to do? Just draw a tangent at that point. That will be giving you the direction of magnetic field at that point. ठीक है? Second one. Done? Okay. Then, is there any method by which we can understand the magnitude of magnetic field lines? Matlab, just by looking into the field lines, is there any method by which we can understand, okay, the magnetic field at this position is more and at that position is less? Yes, by looking into the magnetic field density, line density, okay? By looking into the density of the lines, we can say that whether the magnetic field is more or less. Directly at the polar regions, isn't the density of field lines so more? Matlab, are the lines so much crowded? Yes. So wherever the density is more, wherever the magnetic field lines are crowded, there the field will also be more, right? More is the density, okay? More will be the magnetic field strength. Okay, if it is less, it simply means that the magnetic field strength is less at that point. Okay, Rohan, हाँ बिल्कुल Rohan. और क्या? Okay, write down each and every point, and we already know Can two magnetic field lines intersect each other? बिल्कुल नहीं, because if they intersect at that point there will be two different directions for magnetic field, which is not possible. मतलब देखिए, this is one magnetic field line, let's say. This is another magnetic field line. At this point they are intersecting, which means if we try to draw a tangent at this particular point, we can have two tangents. One tangent will be ऐसे, other tangent will be ऐसे. Matlab, at a point we'll have two different directions for magnetic field, which is not possible. Okay, as that is not possible, we'll say two magnetic field lines cannot intersect each other, whatever happens in this world. Okay, yes, is it clear? Sana and Miara, come back to the class. Okay, else I am going to drop a perichai in all your rooms. Okay, so have you written down all these points, bacha log? Yep, Rashi. Okay. Okay, very good, very good, very good. Okay. Now, two more things are there. Before we proceed further, you can note it down. Everyone, ये भी note कर ले बच्चा लोग. This is very important. Okay, Lakshmi, good evening, good evening. One is pole strength. Okay, ये pole strength क्या होता है? Which is usually represented with the simple n. Okay, so pole strength is a physical quantity which tells how much strength is associated with the pole of a given magnet. ये हमारा magnet है, north and south. Okay, so how much strength is associated with the poles, that is expressed with the help of pole strength. North pole is represented as plus n and south pole is represented as minus n. Okay, and length of the magnet is all the time expressed as 2L. 2L is not twice the length, right? 2L is the total length of a given magnet, because it is expressed as 2L for calculation simplicity. So what will be L? L is the distance from the center of the magnet to one of the poles. Okay, so 2 L's will make it as 2L. Done? Note kar le, I have told you two things right now. What is a pole strength? It's a scalar quantity. It tells how much strength is associated with the poles of a magnet. 2L, the total length of a magnet. Okay, and last one, magnetic dipole moment. Okay, now ये magnetic dipole moment क्या होता है, which is expressed with the large or the capital. How many of you know? किस किस बच्चा को पता है ये magnetic dipole moment क्या होता है? Any idea? आयशा, good evening. हाँ श्रेय, इसका यूनिट तो एम्पियर मीटर. Those who don't know, you can also write this down. Pole strength है ना, उसका यूनिट एम्पियर मीटर. Very good, Shreya. That's a good, very good update. So, how many of you know magnetic dipole moment ये क्या होता है? किसी को भी पता है? अरे, magnetic dipole moment is a physical quantity which talks about total strength of a magnet. What is it? It talks about total strength of a magnet. And how will you find out this total strength of magnetic dipole moment? कैसे करेगा? It is pole strength m into the length of the given magnet. Now, you'll be asking, sir, it looks like a vector quantity, is it so? Yes, it is a vector quantity. Now, you'll be asking, sir, if it's a vector, there has to be direction. So, what is the direction? It is directed from south towards north. This is the south, this is the north. So, from south to north is the direction of magnetic dipole moment. हो गया. Hi, Kushali. Just like electric dipole moment, right? I'm not going for this huge explanation because obviously you know that it's a crash course, right? So we don't have time for a very big explanation with each and everything. So I'm just cut shorting everything, and we are mainly focusing on definitions and important formulas and the units. So is it clear till this part? Is it clear till this part? Kushali, Miara, Sanchana, everyone? Jaldi bol de, because we have a small more concepts to learn, right? Then after that we can start doing the problems. Clear? Kushali? Yes. Sudeep? Sanchana? Miara? Okay. So have you all noted down? Note B here. Okay. So 2-3 more formulas. Write this down. After this, we'll start doing the questions. Okay. Clear, right? Okay. Good, good, good. Can you see a magnet? Okay. So we have a magnet north and south, obviously of length 2n, and a dipole moment is from south to north. We also already have discussed all these things. Now, this is the axis, है ना? A line joining north pole and south pole. If you extrapolate, this will be your axial line. Okay. If you have a point, can you see this point, which is at a distance of r from the center? What is r? R is the distance of the point from the center of a given bar magnet. Its magnetic field on this axial point is defined as formula. Everyone, note it down and also tell along with me. Mu naught divided by 2 pi. Mu naught is permeability, everyone knows. 2 m. What is m? Magnetic dipole moment. R is the distance of this axial point from the center divided by r square minus L. What is L? Half the distance of this given magnet, because 2L is the total distance, L is half the distance, and from the center to one of the poles, the whole square. So this is the formula to find out magnetic field on an axial point which is at a distance of r. This is the actual formula. Note कर रहा है? Note भी कर ले. Okay. And if this L है ना, L का value, if it is very smaller than r, if L is very much smaller compared to this r, where r is the distance from the center to the point, okay, what हो जाएगा? R square minus L square, R square हो जाएगा. It is squared again, r raised to 4, right? I hope you are getting it. Just look into the formula. If r is very much greater than L, r square minus L square हो जाएगा r square. Okay, r square the whole square will be r raised to 4. So r by r raised to 4 कितना हो जाएगा? R cube, 1 r cancel हो जाएगा. So in the case of r very much bigger than L, value for magnetic field on its axial point is mu naught by 2 pi 2m by r cube. Can we use this equation all the time? बिल्कुल नहीं. In which case? In that case of L very much छोटू, मतलब if the magnet's length है ना बहुत छोटा compared to this distance r है ना, in that case we can use this formula. नहीं तो this is our actual formula. Note किया? जल्दी 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 जल्दी. Note किया है ना? Okay. Do you have any doubts related to any of the terms that you have used here? And while you note down the formula, okay, specify what is M, what is R, what is L and everything, so that you won't be having any confusions later. Okay. Yes. Okay. Similarly, next what we have is equatorial position. मतलब ये हमारा magnet है, north pole and south pole, where there is a magnetic dipole moment from south to north, bigger है. If you are choosing a point on perpendicular bisector, मतलब from the center of the given magnet, I am drawing a perpendicular. नाम क्या होता है? Perpendicular bisector. We also call it as an equatorial position, right? On this, if you are considering a point, okay, which is a distance of r, on its equatorial point, the value of magnetic field will be equal to mu naught by 4 pi. Write down m by r square plus L square, the whole power 3 by 2. R we already have defined from the center to the point. L, half the length of a given magnet, mu naught by 4 pi. You know what is M? Magnetic dipole moment. One thing note kar le, there will be a negative sign which shows that the direction of magnetic field at this point is exactly opposite, matlab towards left, because the direction of magnetic dipole moment, as you can see, is from south to north, which is towards right. Okay, so on the equatorial point, the direction of magnetic field will be towards which direction? Towards left direction. Or you can say, as there is negative sign, it will be always opposite to the direction of magnetic dipole moment. Is it clear? Okay, note down the formulas. Obviously, I'm not deriving anything because crash course है हमारा. We'll be mainly discussing on all the basic definitions and formulas. Here, if R is very much greater than L, R is very much greater than L, formula for B will be mu naught divided by 4 pi minus m divided by R square plus L square. कितना हो जाएगा बच्चे लोग? R square plus L square, R square, because L तो छोटू है, R तो बड़ा है. Whole power 3 by 2, 2 cancel हो जाएगा, R cube. So magnetic field on equatorial position is mu naught by 4 pi minus m by R cube, minus opposite direction, to show the opposite direction, m by R cube. अरे बिल्कुल बिल्कुल Zulu. Okay, because I think you might have seen all these formulas while you have learned the formula for electric field in the case of electric dipole, right? While you were learning the electric dipole chapter, right? While finding out the electric field at each and every point, wasn't the same kind of formula that you have used here? So it's the same. Is it clear? Okay. Yes. Now, if it is not an axial or not an equatorial position, right? Someone asking you what is the value for a magnetic field at some point P, which is at a distance of R from the center and makes an angle of theta. Okay, at random point, neither axial nor equatorial, value of magnetic field will be mu naught by 4 pi m by R cube root of 3 cos square theta plus 1. This is also super important. अनुराग सैनी सर, आप कितने पढ़े हो? मैं तो +2 पास करके इधर ऐसे ही आ गया आप लोगों को पढ़ाने के लिए. अनअकैडमी बोल रही है एक ऑफर है, आप इधर आ जाओ. मैं भी सोचा कि हाँ +2 के बाद थोड़ा काम करेंगे, ऐसे आ गया. अरे नहीं, मैं तो आई कंप्लीटेड माय बीटेक फ्रॉम NIT कैलिकट इन मैकेनिकल. ओके, सो आजा. So हो गया. Is it clear? Clear till this part? 2 more formulas. After that we are going to start MCQ. ठीक है बच्चा लोग? हाँ Vishu. So how was it? Were you able to crack all the questions and give the answer for all of them? Sir, what that root 1 depends? Root 1. Root of 3 cos square theta plus 1. ये theta है ना? Where the point is, right? What is the angle made by the distance from the center to the point with the magnetic dipole moment? वो theta होता है. So according to the value of theta, obviously magnetic field will also change. Okay, so last 3 formulas we have to start with the MCQs, है ना? So देख ले. If we have a magnetic dipole, मतलब a north and a south, in an external magnetic field B, and if you are having an angle theta between them, right, this given bar magnet will be experiencing a torque. Formula for torque, mb sine theta or m cross b. Write down, very important. Okay, so this will be experiencing a torque and this will start rotating, first thing. Then it will be associated with a potential energy. What will be associated? The given magnetic dipole. Formula for potential energy associated with the bar magnet when it makes an angle theta is minus m magnetic dipole moment. B is magnetic field cos of the angle theta. Okay. Then last concept is how to find out the work done while you rotate this particular bar magnet from an initial angle of theta 1 to a new position of theta 2. समझ में आ गया? From one position, you are rotating it to a new position, right? Questions will be how to find the work done for such rotation. Formula: final potential energy minus initial potential energy. What's the formula for potential energy? देख ले, minus mb cos, finally angle is theta 2 minus. What is u1? Initial potential energy minus mb cos theta 1. So minus of minus will become plus. So you can say mb cos theta 1 minus mb cos theta 2. Okay, this is not the general formula. This is a specific formula when you rotate it from an angle of 0 to some angle theta. We don't want to learn that. We want to learn that general formula that you can use it all the time. So better by heart this. Okay. जल्दी 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 जल्दी. अरे सर इज मैरिड. अरे ये सब इसका जरूरत क्या है जब मैं मैरिड हूँ या नहीं मैरिड हूँ. ठीक है, मुझे बच्चे हैं या नहीं बच्चे हैं. ओके, सो मेरा शादी हो गया तो शादी के बीच में कोई प्रॉब्लम है आपको और आपका वाइफ के बीच में कोई प्रॉब्लम है क्या? क्या क्या क्वेश्चन पूछेगा आप लोग. हाँ, अरे बाप रे, फिजिक्स का एक ही क्वेश्चन नहीं पूछेगा. ओके, पर्सनल क्वेश्चन इतना पूछेगा, इतना पूछेगा. अरे सुधर जाओ मेरे बच्चा लोग. पता नहीं मैं क्या बोलूं. ओके, क्वेश्चन तो शुरू करेगा. ओके, प्लीज डू वॉच द रिप्ले आना. ठीक है, प्लीज डू वॉच द रिप्ले. Done everyone? Okay, so shall we start everyone? Shall we start? जल्दी 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 जल्दी. Sana is like, don't make your fans sad. Arey, I'm not here to build any fans. I'm just here so that I can help you in the best way possible for your examinations. ठीक है? So, bachalo, can you all see the questions? It's a very beautiful question. So try to do it. I'll be so happy to that person, not that person who's give me the correct answer. Everyone, whoever tries it. Everyone, bachalo, try kar le. Whatever you know, according to the formula we have discussed till now, है ना? So try in the best way possible for giving the answer. वही है. कूलस तेरा मेरा नाम लीजिए. अरे आपका नाम तो मैं कहाँ से ढूंढूं? आपका नाम तो इधर नहीं है. कूलस लिखा है, तो आपका नाम किधर है? सो एमसीजी बोल रहा है कि हमारा ऑप्शन बी है. ओके, खुशहाली से इट्स ऑप्शन डी. देन who we have? Sudeep is like, sir, option C locked. Very good, Sudeep. Even in your bad health, if you're this attentive, you can do anything. Nothing is impossible for you. ठीक है संजना. I'll wait 15 seconds more last. कर ले आप लोग. Then म्यारा A और C. DB status sir, C is right. Okay. हाँ वेट करेगा 15 seconds. Last 15 seconds. Okay. So those who want to give the answer last 50. I know that the question is a bit lengthy. So इसलिए मैं थोड़ा और वेट करेगा, थोड़ा और. सर माय नेम इज अमीर. अरे वो तो मेरा नाम है. हाँ, चुराया है क्या तू मेरा नाम? सी बोल रहा है. Okay, 10 centimeters and I is like C, Arno. So yes, very good मेरा बच्चा लोग. Option C is the correct answer. Very good. Anurag Saini, yes, C is our correct answer. Let's see. देख ले बच्चा. Distance of 2 points on the axis of a magnet from its center is 10 centimeters and 20 centimeters. मतलब this is our magnet. From the center, we have the first point, which is at a distance of 10 centimeter. From the center, we have another point P2, which is at a distance of 20 centimeter. This is given. Okay. A ratio of magnetic field at this point is 12.5:1. Matlab, if I mark the magnetic field at this position as B1, okay. If I mark the magnetic field at this position as B2, what is given in the question? In the question, it is given that ratio of magnetic field, matlab B1 by B2 is equal to 12.5. Can I write this as 25 divided by 2? Right? because ratios are much more good to do than with decimal points. Okay. Question here, the length of the magnet will be, so obviously you know that total length of the magnet is 2L. So here 2L kitna hai? That's what need to find out. How will we do? If you simply know the formula for magnetic field on the axial point, उत्तर ऐसे ही आ जाएगा. Tell me what's the formula magnetic field का? याद है? Mu naught by 4 pi. फिर 2. Magnetic dipole moment is the same magnet, so I'm putting it as M, not putting it as M1 and M2. Then R1, isn't it? The distance from the center to the point. The whole divided by, फिर क्या है? Yes, R1 square minus L square, the whole square. Isn't this a formula? Divided by magnetic field at the second point, B2. Substitute कर ले. Mu naught by 4 pi. 2m. Why am I not writing m1 and m2? Because it's the same magnet have same magnetic dipole moment. So here we have r2 whole divided by r2 square minus l square, the whole square, is equal to 25 by 2. What all you can cancel कर ले. Mu naught by 4 pi, mu naught by 4 pi हो गया. 2m हो गया. Then what do you have? R1 by R2, isn't it? We'll continue here. Okay, we have so much of space. We'll continue here. So R1 by R1 कितना है? What the first distance? 10. So 10 divided by 10 square minus L square, the whole square. Okay. R2 will be the denominator. R2 कितना? 20. So R2 square minus L square, the whole square, will be going to the numerator. ठीक है. So R2 कितना? Once again 20 square minus L square, the whole square is equal to 25 by 2. Okay. Now तो हो गया. If you have understood till here हो गया. देख ले. 10 by 20 is 1 by 2. Okay. देख ले how I cancelling each other. So 10 by 20 is 1 by 2. ये 2 cancel कर ले. हो गया. So 20 square minus L square by 10 square minus L square, the whole square is 25. Taking roots. So both the sides, chalo, roots. Take roots on either sides of the equation. How much will it be? 20 square minus L square by 10 square minus L square is root of 25. 5. Now cross multiply. 20 square is 400 minus L square. So 10 square is 100 into 5 is 500 minus 5 L square. So minus 5 when it comes to the left kitna? 4 minus 1 4 L square. 500 minus 400 100. L square is 100 by 4, that's equal to 25. So L kitna? 5. So don't jump and write the answer as A. Is the answer for length of the magnet 5? सोच कर बता. Is the length of the magnet 5 centimeter? अनुराग साइनी मत कर ले, प्लीज डोंट स्पैम. मैं तो सोता हूँ बिल्कुल. It's 2L. What we got is L, the length of the magnet, है ना बच्चा लोग देख ले. Length of the magnet 2L है, L नहीं है. So 2 times L का value 5. So 2 times 5 कितना? 10. देख ले. Those who made the question कितना चालू लोग है? They made the option A itself as 5. Because the moment after doing this big calculation, you will almost forget to take 2L. So when you get the answer L equal to 5, you'll be so happy. हाँ बिल्कुल मुझे उत्तर मिल गया. You'll go with the option A. तू मार्क करेगा तो हो गया. Okay, -1 तो मिल गया. So हमारा correct option C है, where it is 2L. Is it clear? Yes. Okay. So yes. So moving on. We'll do one more question before we proceed further. Okay. Now I hope you understood what was your mistake. Okay. And I hope you made the corrections. Do this. Bacha log. The work done in rotating a magnet, okay, of dipole moment दे दिया है 2, मैग्नेटिक फील्ड दे दिया है फ्रॉम द डायरेक्शन along the field to opposite direction to the field is. It's very simple. I have already told you how to find the work done. अरे don't scare me again. मैं क्या किया? हाँ? Do I look so scary? So I can see the answers popping up in the chat box. First person Khushali with option C बोल रहा है. Then Zolu Tanwar with A0. Okay. अरे मुझे मजाक कर रहा है ना मुझे ऊपर मेरा. ठीक है मैं दिखाऊंगा तुझे. ठीक है. So Khushali is like there should be minus. So anyway, you are going to lock with the option B, I suppose, right, Khushali? Shreya is also like, sir, B is the option. बढ़िया बात है देखा. Can't able to think. Okay, so I got some options as B, somewhere telling with C है ना. So correct option. Okay, अजय बोल रहा है कि B, MCG बोल रहा है कि A. So हमारा correct option B है बच्चा लोग. हमारा correct option B है. Let's see how it can be done. देखिए, everyone, listen here. Question is work done. When you rotate a magnet in an external magnetic field, what's the formula for work done? Alright, 2-3 pages before I have told you. I'm not going for the derivation once again. देख ले, mb cos theta 1 minus mb cos theta 2. Didn't I tell you? Yes. So, work done formula, once you rotate a magnetic dipole, I'm writing the formula directly. mb cos theta 1 minus mb cos theta 2. Common क्या है? mb. Cos of, tell me, what is theta 1? Read the question. From the direction along the magnetic field. मतलब initially है ना बच्चा लोग देख ले. We have a magnet. Magnetic dipole moment is from south to north. There is a magnetic field is also from south to north. मतलब both of them were in the same direction initially. That is what given in the question. So theta 1 क्या होता है? 0. है ना? So cos theta 1, I'm going to put it as 0 minus mb cos. Okay, mb is outside the bracket है ना? So ठीक है. Theta 2 कितना? अरे to opposite direction. मतलब you are rotating this magnet, okay, and you are going to keep the magnet ऐसे. मतलब south north ऐसे. Magnetic field B will be towards right itself. Tell me what's the angle now? Angle कितना? 180 degree. Both of them are opposite. Okay, one is towards left, one is towards right, so angle is 180 degree. So cos 180. Cos 180 कितना? Minus 1. Minus of minus plus. Cos 0 is 1. So 1 plus 1 is 2. So answer is 2 mb. है ना? 2. M दे दिया क्या? Of course, it's given as 2. Magnetic field as 5 into 10 power minus 3. 5 is 10 into 2, 20 into 10 power minus 3 or 2 into 10 power minus 2 joules. Okay? बिल्कुल नेगेटिव भी नहीं है ना? नेगेटिव भी नहीं है, कुछ भी नहीं है. हमको we got the same answer भी. Okay? Yes. Clear? Smiling faces. Let me see the smiling faces. Okay? If you have any doubts, let me know बच्चा लोग. And if you don't have any, जल्दी नोट कर ले पूरा का पूरा. Okay. Is there a beep sound? समझ गया था ना? Okay. Is there a beep sound? समझ गया? Okay. Is there a beep sound? समझ गया? Okay. अब है क्या? Maybe because I'm keeping my phone so close. So, is there a sound right now? So, okay, I think there is. Okay, so tomorrow let me get it more sorted out. I tried in my own way, so पता नहीं क्यों नहीं sort हो गया. So कल तो पक्का. Okay, it'll be sorted. कोई बात. All clear खुशहाली. Okay, छोटू छोटू sound. Okay, फिर तो बढ़िया. Now moving on. CV lesson class will end. Okay, so पता नहीं what it is, right? Not a disturbance, right? It's very mild. Okay, so anyway, obviously if it's a disturbance tomorrow we have to get it sorted, है ना? I'll get it sorted. So tomorrow, today after the first class, मतलब it almost ended by 9:40 कुछ. I got any 5 minutes, so I just ran and had my food and came back. So I couldn't get the time to call any tech person. So I tried in my own way, but it couldn't happen anyway. Seems like it couldn't happen. I thought it was corrected. Anyway, we'll proceed. Okay, coming back, everyone. बच्चा लोग आ जाइए. So yes, let us continue with our concept. देख ले, a current carrying conductor, right? And if there is a current carrying conductor in a circular loop which has an n turn, है ना, this current carrying dipole, मतलब sorry, not current carrying a dipole, a current carrying loop will be acting exactly like a bar magnet or a magnetic dipole. मतलब this given bar magnet and this current carrying loop will be acting exactly the same. That's what is being said here. So here for this particular magnet, how did we find out the magnetic dipole moment? That was found out as pole strength into length of the magnet. This we already have discussed, isn't it? Now you'll be asking, sir, if a current carrying loop is considered as a magnetic dipole, how will we find out the dipole moment of this current carrying loop? Formula, देख लें. Magnetic dipole moment of a current carrying loop of n turns is number of turns into the current it carries into the area. A is the area of the loop. Obviously circle है, circle का area how will you find out? Pi r square. Not a big deal, isn't it? Yes. Now one thing you can ask me. Okay, one thing you can ask me, बच्चा लोग. What is it? Yes, ये पूछ ले, sir, isn't magnetic dipole moment a vector quantity? Because we know that it's a vector quantity. If it was a bar magnet, we know it is from south to north, मतलब upwards here in this case. So for a current carrying loop, how will you find the direction of magnetic dipole moment? कैसे? Those who have right hand can easily find the direction. What do you have to do? Take your right hand, curl your fingers in the same direction of the current carrying loop. In this figure, how the current is moving? How the current is moving? In the anti-clockwise, है ना? So, curl your fingers in the anti-clockwise direction. अरे बाप रे बाप, क्यों चिल्ला रहा है ये कुत्ता लोग? पता नहीं क्या हो गया. हाँ. So I think their problem is settled, है ना? So I think dogs found a solution for their own problems. I think now sound is not coming. ठीक है. So what I was telling, how to find the direction, right? So curl your fingers in the direction of the current. So here you can see the picture that current is taken anti-clockwise. So curl your fingers in the anti-clockwise. Whatever is the direction of the thumb, that is the direction of what? Magnetic dipole moment. So here, as you can see, what is the direction given by the thumb? Upward. So for this particular configuration, the direction of magnetic dipole moment is upwards or plus k. Okay. Is it? Okay. Did the dog see a ghost? वो तो उधर जाकर पूछना ही पड़ेगा, है ना? And if I go there and ask the dog this particular thing, instead of answering me, what they will be doing? आपको भी, तुझे भी बताया ना, सबको बताया. हाँ, ऐसे भौंकर मुझे काटेगा. And for 2-3 weeks, आप सब लोगों को मेरा क्लास भी नहीं हो जाएगा, ठीक है? And मुझे सैलरी भी नहीं मिल जाएगा. That will be the end story. तो ठीक है, मिल गया. हाउ टू फाइंड द मैग्नीट्यूड, हाउ टू फाइंड द डायरेक्शन. ठीक है सर. अ सिंगल टर्न कॉइल इज आल्सो अ डाइपोल. बिल्कुल खुशहाली, और क्या. फॉर दैट नंबर ऑफ टर्न इज इक्वल टू 1. ठीक है, डाइपोल मोमेंट का स्ट्रेंथ कम हो जाएगा बस. ओके ओके, मूविंग ऑन. ओके, वन लास्ट थिंग बच्चा लोग, गॉस लॉ इन मैग्नेटिज्म. डू यू रिमेंबर गॉस लॉ इन इलेक्ट्रोस्टैटिक्स which says that E dot ds मतलब the surface integral of electric field over a closed surface is equal to 1 by epsilon 0 times the charge it encloses. You remember? Do you remember? Okay. Then similarly, in the case of magnetism, what you have is, if you consider a closed loop here, which is called as Gaussian surface, it says integral B dot dA. B is magnetic field, A is the total surface area. Matlab, if you find out the total magnetic flux, associated with this entire closed loop, उसका value कितना हो जाएगा? 0. The total magnetic flux associated with any closed loop is found to be 0. बाप रे बाप, ऐसे कैसे? How many of you have thought this? If you are considering a closed surface, in any case it is going to be 0. Do you know why? देख ले, you take a closed surface, right? Inside this, let's say that I'm going to keep a bar magnet. If a bar magnet is there, obviously magnetic field lines are associated with it, right? It starts from north, I say, move toward the south, and from the south it will be moving toward the north. It will be making a closed loop, right? ये सबको पता है. So yes, if there is a magnet, you may think on the first look that field lines are associated with this closed surface, matlab a flux is associated, but closely observing you will find out that it is 0. How the flux associated with this closed surface is 0 even though field lines are associated with it? Very simple. From the north pole, field lines are emerging out. Matlab, from here, the field lines are emerging out. So I'll be marking it as plus 5. Okay, because field lines coming out is plus. So you just look that at the other end of the area, it is coming inside. So coming inside field lines are marked with negative. So what will be the total flux? Plus phi1 plus minus phi1 matlab cancel ho jayega. So whatever the flux lines coming outside, same is the flux lines coming inside. And this also tells one more thing. Do you know what? In all the cases, if flux lines associated with the surface is 0, it simply means, yes, the bar magnet will always be existing as dipole. Matlab, always it will be with the north and south. Okay, even if you cut this magnet, what happens? Two different magnets will be formed with north poles and south pole. इसका मतलब ये है कि monopoles है ना. Matlab, you cannot have a magnet with north pole or south pole alone. This doesn't exist. Okay, magnetic monopoles doesn't exist. This is the outcome of Gauss law. Okay, ये भी लिख ले. So from Gauss law of magnetism, what's the conclusion we can make? Conclusion ये कि everybody write down the conclusion. बच्चा लोग. Conclusion from Gauss law. Okay, others are not that important. Conclusion is monopoles doesn't exist. What monopoles? If you want to make it more specific, है ना बच्चा लोग, ये लिख ले. Magnetic monopoles doesn't exist. Okay, written. This is a conclusion from what? From Gauss law in magnetism, and please do remember this also. Okay, this particular statement related to Gauss law. That's all about this part. Write down the formula. Okay, Menti, we will start around how much more is left? Okay, we'll start around 11:10. Okay, exactly at 11:10 we'll start our Menti, which leaves us with 15 minutes more. Okay, Very good, Neelam. Very good. So happy. So just give me the answer if you have already learned this. Jaldi se. Okay. Okay. Someone is like, shh. क्या हो रहा है? Huh? Yeah, sure, sir. Sure. Take your time. But I don't think you need that much of time for solving this particular problem. It's not a big one. Answers. Okay, so the answer starts flowing or started flowing into the chat box right now. I can see that from Kushali. I can see with the option A. Then what do we have? Then Miara is like, is it option C? आप लोग ही देख ले. Or D. Neelam, you already completed the chapter. I want answers as soon as possible from you. Sudeep is like, C sir, pakka. जल्दी. Are you on Instagram? बिल्कुल नहीं. I have no idea what Instagram it is. So, shall we? Everyone, देख ले. Everyone is like option C बोल रहा है. ठीक है, तो करेगा. Okay, so let's see. I'm not telling you whether the option is A, B, C, or D. Let's find out. Okay. Circular coil. We have 16 turns, right? Radius तो 10 centimeter मतलब 10 centimeter 0.1 meter. No doubts, है ना? Carrying a current of 0.7 ampere, right? Rests with its plane parallel to the horizontal surface. If current is anti-clockwise, find magnetic dipole moment. Okay, tell me first, what is the formula for magnetic dipole moment? NIA, right? Starting with N, 16. Okay, I kitna 0.75 or 3 by 4, let's say. Current 0.75 is 3 by 4. Area is pi r square. R is 0.1. So square of it is 0.1 the whole square, that is 10 power minus 2. Okay, so 16 by 4, it's 4, right? So 3 3s are 9, 9 point something, right? This will be how much? 9 into 4, 36. So 3 3s are 9, almost we can say that it's 10. So 4 into 10, it's 40, right? And into 10 power minus 2 is 0.4 ampere meter square. So actually have what I have made a small this है ना. So instead of 0.4 वो थोड़ा it will be more close to 0.3. So the answer very close to 0.4 is 0.3. I hope you understood, because 3 into 3.14 is not 10. आपको भी पता है. So it will be a value 4 into 10. If we approximate as 3 into 3.14 as 10, the answer will be 40, but it is not 10. So it will be a bit lesser than that. So 0.3 we can go for, right? Okay, with the unit of ampere meter square. Then we have three options. Option A and B is there, upwards and downwards. So let's see. What's the direction of current? Anti-clockwise. How will you find direction of magnetic dipole moment? Chalo, take your right hand. Okay. Curl your fingers in the anti-clockwise direction. What's the direction shown by your thumb? Outwards. है ना? So you can say outwards or upwards as your answer. So which option? We can go with the option A. Okay. Yes. अमित राणा ऑप्शन ए बोल रहा है. हाँ, very good. Everyone is with the option A right now. Very good. अरे अमित. Okay, मुझे भी. What do you say? There is a ad है ना which says घर भी old हो गया और मैं भी old हो गया तो grandpa हो रहा है मैं तो आगे it's not so good इसीलिए okay माफ कर दे who is it अमित है ना okay you also gave me the same answer option A good okay Anna understood with a punjiri with a smiling face amazing so anyone who's having any confusions anyone do anyone have a confusion here so you're the best Arre baap re. Thank you okay so I hope everyone is clear on how to deal with this problem so yes we'll go with the last concept for today's class okay after this we'll start with our mentee ठीक है हमारा mentee है ना at 11:10 sharp I am planning to start with our classes clarified okay no worries Amit okay देख ले ये हमारा earth है so this is the north pole of our earth and this is the south pole of our earth if you draw a line connecting the north pole of the earth and south pole of the earth we call it as geographic axis okay ठीक है we know that earth is acting like a magnet मतलब magnetic field is produced by the earth okay and if we observe the magnetic field lines produced by the earth it feels like a bar magnet is hidden inside the center of the earth I'm not telling there is a bar magnet inside the earth but the magnetic field lines produced by the earth makes all of us believe that there is a bar magnet which is well hidden inside at the center of the earth and how it is kept where the north pole of the magnet is kept almost close to the geographic south and the south pole of the magnet as you can see is kept almost close to the north pole of the earth right if you connect a line between the north pole of the magnet and the south pole of the magnet we call that as magnetic axis okay now, can you see an angle formed between the magnetic axis and geographic axis? Obviously, they are not aligned together. Okay, so there is an angle between the geographic axis and magnetic axis, and that angle is found to be almost 11.3 degrees. Okay, zoom karna hai, I'll just draw it. Okay, I'll draw my own figure. Right, my circle won't be as good as though. ये north है ना, ये south. Okay, so if you draw a line connecting these two, okay, this is the north pole of our Earth and south pole of our Earth. इसका नाम है right geographic axis. Okay, now the magnetic field produced by the Earth makes us feel that there is a bar magnet kept well inside the surface, and how it is kept? South pole here and the north pole here. Right? If you connect a line between the north pole and south pole of the bar magnet or the assumed bar magnet, right, we are having a magnetic axis. Okay? Can you see an angle formed between them? This angle is found to be 11.3 degree. Angle between हमारा magnetic axis and geographic axis. ये भी note कर लो. Okay? Okay? Yes? Next, magnetic declination क्या होता है? I think many of you are having doubts with this angle, that angle, है ना? So, first, for understanding and defining what is magnetic declination, ठीक है? You should be knowing बच्चे लोग what is geographical meridian and magnetic meridian. ये सुन ले पहले. Geographical meridian क्या होता है? So ये हमारा Earth है. Okay. So try to think. Obviously, I cannot draw. It is completely three-dimensional. Let's say here we have a point on the Earth. I want to draw a geographic meridian at that point. What will you do? You'll just drop a plane passing through that point and the geographic axis. Can you see the axis? Can you see this axis? So passing through that point, drop a plane which also passes through the geographic axis. That will be what? What will that be? Geographical meridian. So how will you draw a magnetic meridian at that particular point? Obviously, drop a plane passing through the same point, but along which axis? Along the magnetic axis, right? So drop a plane. So what you will get is a magnetic meridian. So you can see that an angle is formed between them. An angle is formed between the geographical meridian and magnetic meridian, and that angle is called as magnetic declination. Okay, very good, Sanjana, amazing. Yes, that it is. Right, बच्चा लोग, only 2-3 more minutes. We are going to start with our Menti. जल्दी से. Okay, one last concept, angle of dip. What is this angle of dip? देख ले. If this is our surface of the Earth surface, right? At this point on the surface of the Earth, let's say the Earth is producing a magnetic field in this direction. The net magnetic field at this point is B in this direction. Let's say it make an angle of I. ये एंगल है ना, ये एंगल का नाम है एंगल ऑफ डिप और एंगल ऑफ इंक्लिनेशन. What is it? It is the angle formed between the horizontal surface of the earth with the net magnetic field present at that point. Can you see that angle? वो होता है हमारा angle of dip I. Okay. From here, if we have angle of dip, two things हम बच्चा लोग हमको we can find out. What all are they? One is the horizontal component of magnetic field कितना होता है? B cos I, isn't it? The component of magnetic field along the surface of the earth with the name of horizontal component of magnetic field B cos I होता है, of course. And what about the vertical component? That will be the away component, that is B sin I होता है, we call it as vertical component of magnetic field. And what will be vertical component of magnetic field to horizontal component? That will be B sin I by B cos I. वो कितना होता है? Tan I or phi, whatever is the symbol you are using. So B vertical by B horizontal will be equal to tan of angle of dip. Clear? And obviously, if BH and BV are two perpendicular components of magnetic field B, you all know how can you write B as root of BH square plus BV square. All these are simple vector concept which you already have learned from your first year. So हो गया? Is it clear? Can you please watch the replay, Khushali? Or if you still have doubt, please do text me in our Telegram. I'll clear it to you. Okay? Yes, crystal clear. Okay. Okay, do this problem, and after this we'll be starting with our Menti. Last question before our Menti. Last question. Last, the final last, the very last. Amit, you can text me. You can find me with the name of Ameer Basith, right? So just text me. I'll tell you. I'll send you the link. Okay. Okay. I'll sing a song for you today. Okay. Now throat is fine. Thank you so much for asking anyway. So anyone with the answer is come? Just think you'll get the answer. So Deep was like, A sir, maybe. Okay. Taken into consideration. I'll wait for 10 more seconds. Anyone? और कोई है क्या with the answer? Does anyone else have an answer? Vishali, Aditya, or with the option C बोल रहा है. C किधर? 10 past 16. Okay. Mira is like, is it B sir? Ms is like D, I thought. Last 10 you all have? Okay, that is a very good guess, Mira. Okay, any of the above options, very good. I'm seeing a very bright future in you. B maybe. Okay, the correct answer is option A. Take everyone. The magnetic field of Earth at the equator is approximately 4 into 10 power minus 5 Tesla. Radius of the earth is 6.4 into not 106, if that is the thing which made you get the wrong answer. It is 10 power 6. Okay. Then the dipole moment of the earth will be nearly of the order. This is our earth, right? Inside the surface of the earth, we know that the magnetic field is produced as if a bar magnet is kept inside the center of the earth, right? Okay. Now, question is, what is the magnetic dipole moment of this particular bar magnet? If what? If the magnetic field on the equatorial point is given as 4 into 10 power minus 5. Tell me, what is the situation here? This point on the equator is an equatorial point, matlab a point on the perpendicular bisector of a magnetic dipole. What's the formula for finding the magnitude of magnetic field on an equatorial point for a magnetic dipole? How many of you do remember this? Mu naught divided by 4 pi m divided by r cube. Do you remember? How many of you do remember? Because we started the chapter with this formula, right? Now substitute everything whatever is given. B 4 into 10 power minus 5. Mu naught by 4 pi is 10 power minus 7 m divided by r cube, right? So that is 6.4 into 10 power 6. 6.4 into 10 power 6, the whole cube. Oh yeah, you just need to do the math. That's all that is left. 4 into 10 power minus 5 divided by 10 power minus 7. This will go up. 6 6 are 36, right? Because it's cube. So 6 6. So this will be 6 into 6 into 6. So कितना हो जाएगा? 6 6 are 36. 36 into 6. 6 6 are again 36. 6 3s are 18. 19, 20, 21. So almost we can approximate 6.4 almost as 300. Approximation. I'm not putting equal to. Okay, because it is nearly of the order. That's the question, right? Okay, 10 power 6, the whole cube is 10 power 18. So ये कितना हो जाएगा? 4 3s are 12, isn't it? 4 3s are 12. Again approximate. So 1200 will be almost approximating it as 10 power 3. ये दोनों 300 into 4. 10 power minus 5 into 10 power 18 and 10 power minus 7 will go up. So 18 plus 7 कितना हो गया? 18, 20, 25 है ना? 25 into 10 power minus 5. So 20, right? 10 power 20. So 10 power 20 into 10 power 3 is 10 power 23. So answer option A. Clear? अरे मेरा क्या हो गया? अरे it's fine. I was just making fun of you. मेरा अरे बाप रे. You took it to your heart. अरे I'm sorry. क्या क्या कहते हैं मेरे बच्चा लोग. Okay, I hope you're fine. अरे पागल है क्या? Okay, you are attending all my classes. You are here on time. You are learning everything. ठीक है? So आप इधर आकर इतना participate करते, you are learning everything. So how can you call yourself as a lame person? हाँ? मैं तो ऐसे ही मजाक कर रहा था आपको. हाँ? अरे just have a smile. Okay. So try to get a very good score in Menti. Last time, अरे यार you got the first rank in last Menti. मेरा स्टार पर्सन है तू क्लास पे जल्दी. ओके सो बच्चा लोग एवरीवन कमिंग बैक. एवरीवन देख ले सना है ना. सो आई यूज्ड टू मेक फन ऑफ सना ऑल द टाइम. Okay, so coming back, shall we start with our Menti? Sana, Sudeep, Myara, everyone, Aditya. Menti का time हो गया और क्या? So here we have the Menti code. Jaldi. So we have the Menti code right in front of us. So everyone, jaldi, 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 jaldi. अरे कोई बात नहीं. If she is happy है ना, if all my बच्चा लोग is happy, और क्या चाहिए मुझे जिंदगी पे, है ना? अरे जल्दी ज्वाइन कर ले Menti पे. So after you join, okay, let me know what is your avatar is. जल्दी जल्दी बता दे. Join everyone. Amit, Khushali, Zolu, Devpriya, Khushali, Mom's Queen, Sanchana, Myara. Amit, watermelon. Okay, clear? No one else. I know that it's watermelon from Amit. Others? Okay, Mom's Queen, जल्दी आ जाओ. दौड़ आ जा. Tiger, Sanjana. Okay, so you got such a strong character today, right? नहीं हो रहा, एक और बात try कर ले. देख ले, the code is on the top. 44526379. So please see last part. How is it 10 power 3? It's 10 power 3 है. 1000. I think it was 300 into 4 है ना. 1200. We approximated it as 10 power 3. 1000 is 10 power 3 है ना खुशहाली, है ना? और क्या? Sana is lion's income. अरे. So today everybody got a very good avatar. It seems like. Sana Singham. So I'm going to start the session. Shall we? What do you all say? Okay, shall we, everyone? In 5, 4, 3, 2, 1. Yeah, can you please restart or refresh? Okay, then everything will be there. So yes, so here we are moving for the very first question. It's very chotu question. Most of the questions are conceptual questions in today's class. So last 50 seconds we all have. Everybody has voted. Result is loading. Okay. Very good. Wow, wow. I got a cool set of students. Brilliant. Very good. Let me see who are these 6 students who got the correct answer. Vishu, the fastest person. Amit, we have then. Amit, very good. You are telling no one is minding you. Dekhle, you came on the second position. Very good. Zolu, Mudilappa Ala Vidum. What is it? Then we have proud of Ameer sir. So who was this person? Sanjana or Sana? Someone was ये कौन है? Tiger है, lion है? So मैं भूल गया. Okay, Endado why? बात है. Who is this person? Who is the host person? अरे यार, क्या क्या नाम रखा आप लोगों ने? देख ले बच्चा, देख ले everyone. A magnet of magnetic dipole moment M, okay, and pole strength M is divided into 2 equal parts. Then magnetic dipole moment of each part will be. Let's see. We have a magnet. Pole strength is M, okay, its length is 2L. How will you write its magnetic dipole moment capital M? Pole strength into its length M into 2L. Okay. What are you doing to this particular magnet? You are cutting exactly this particular magnet into half, okay, along its length. So what will happen? So you'll have two different magnets, okay, and if you cut exactly into two equal parts, what will be the length of each? L. Question is to find out its magnetic dipole moment. Okay, what is its length? L. No doubt in this. But what about the magnetic dipole moment? Will there be a change here? देखिए m छोटू m है ना, it corresponds to pole strength. What is pole strength? Pole strength totally depends upon the strength of the poles. मतलब it totally depends upon what? The end surface. Okay, whatever is the end surface, the pole strength depends on that. देख ले, before you cut this particular magnet and after you cut, there is no difference for the end faces. देख ले, the area of the end faces remains the same. If area of the end faces remain the same, strength will also be remaining the same. So the new dipole moment of each and every half part will be equal to the pole strength m, which remain the same, into L. Okay, what is m into L? That is capital M by 2. है ना? Because m into 2L was capital M. So the half of that will be equal to m into L, which is the new dipole moment. ठीक है, ऑप्शन बी मिल गया. समझ में आ गया सबको? Everyone, those who got it wrong or those who are having little troubles in understanding the concept, I hope it's clear. Is it clear? बच्चा लोग जल्दी बोल दे. Okay, Khushali has asked a very good question. Okay, Khushali, even if you cut this particular magnet horizontally, the answer is going to be the same. Okay, Khushali asked a very good doubt. Take it. Khushali is asking, instead of you cut the magnet vertically, right? If you cut the magnet horizontally, what will happen? Or will they be specifying that you have to cut the magnet horizontally or vertically? Obviously, in the main question, they'll be specifying. Let's say, or let's see what happens if you cut it like this. Matlab in the horizontal fashion. Dekh le. Initially, the magnetic dipole moment as before, m into 2l. But now, if you cut it like this in the horizontal fashion, you will get two magnets, ऐसे, where the length of the magnets remains the same. But what happens to this pole strength? Pole strength को क्या हो जाएगा? Initially, this much was the area, and you know the pole strength totally depends upon the end surface, right? Now you are cutting this exactly into half, so half became the area. So what will happen to pole strength? Pole strength will also become half. So the new dipole moment, once you cut it horizontally, कितना हो जाएगा? Pole strength is m by 2 into the length, that is 2l. So कितना? 2 cancel हो गया. ml. ml कितना है? ml is initial magnetic dipole moment half by half. है ना? The new dipole moment is exactly half even if you cut it horizontally or vertically. Okay? Very good, very good. Yes, Kushal. So is it clear, Kushali, Sana? Sana free now, I'm back. Very good. So we have two Sanas in the class. Clear? Yes. Kushali. Awesome, awesome, awesome. Okay. So we are moving for the second question for today's session. Depriya, आपका अवतार bird है. Good. Good, good, Depriya. So finally you got into the Menti, है ना? At last. That's good. Okay, so the next question is here. So this is going to be your first question, Depriya. For others, it's the second question. If you all are ready, bachalo, shuru, huh? What do you all say? With a smile. So I'm going to press the enter key so that you can have the second question right in front of you. Yes. Okay. The distance of 2 points on the axis of a large magnet. Can you add a on the axis of a small magnet? From its center is 10 centimeter and 20 centimeter. Small magnet का मतलब ये है कि है ना, length of the magnet is very small compared to the distance r. Okay, in the question, please do add small magnet to specify that the length of the magnet L is very much smaller compared to r. Last 15 seconds, बच्चा लोग. So everybody has voted. Uh-oh. Only one person got it correct. And let me first see that first one person. Who's that exceptional person here? Aditya Mishra. Very good. Baapre baap. Okay, very good, Aditya. So good. So on the top we have Vishu still, and Amit was on the second position. Then we have Zolu, Mutila, proud of Ameer sir. Indadu Varire. Okay. Let's see how this question can be done. Dekh le. So as I have told you to add a small magnet, right? Okay. Now tell me, if a magnet is given, what is the value of magnetic field on its axial point, on the axis? Okay, what's the value of magnetic field formula? Mu naught divided by 4 pi 2m divided by r cube, isn't it? Yes. So the question is to find out the magnetic field produced by a given magnet at a distance of 10 centimeter to a distance of 20 centimeter. Formula क्या? Mu naught divided by 4 pi 2m by r1 cube, the whole divided by, what is the magnetic field produced at a 20 centimeter formula? Mu naught divided by 4 pi 2m divided by r2 cube. और क्या? समझ में आ गया? Is it? Mu naught by 4 pi cancel, 2m cancel. This will be r2 by r1, the whole cube. What is r2? 20 by 10, the whole cube. What is 2 cube? 8 is to 1. Is it clear now? Okay. Is it clear, मेरे बच्चा लोग? The method we have followed, the equation that we have used, where we have made the substitution, and until it reached the final answer. Is it clear? Okay. Yes. Fine. Done and understood with a smile. Okay. Good, good, good. So, third question is right in front of you. You can go for it. Arey baap re, itna simple question. Simple question. Dip angles are 30 and 45 at two places. What the ratio of horizontal components of Earth magnetic field? Very simple, isn't it? Very simple. One of the simplest, let's say. Simple for me. अरे सबको simple है ये. सच बता रहा हूँ मैं. देख ले Ahmed, Sana is like, okay, give me more these kind of questions. Which simply says simple है ये. Time is up, and अरे क्या हो गया? So let's see what do we have in the leaderboard. So Amit was the fastest. Wow, Amit, wow. Where is Amit? Amit, are you there? Finally on the top, Amit. Very good. Keep it up. Aditya, then Vishnu, Zolu, Mudila, proud of Ameer sir, Endado S. Thankama is back. There, Priya. Okay, so what happened? Arey, this was such a simple question. What happened to you all? Okay. Now, question is, what is the ratio of horizontal component of Earth's magnetic field? Tell me, chalo. Everybody answered. Seems like that Menti को थोड़ा कुछ हो गया देख ले. Just check your answer, okay? Just देख ले, is the answer correct or not? So horizontal component of magnetic field का formula क्या है? B cos theta, right? So question ये कि ratio of horizontal component of magnetic field at the point 1 to the ratio of magnetic field at the point 2. So how will you write it? The magnetic field at the point 1, B is a constant, into cos of theta is 30 divided by B into cos 45. Cos 30 root 3 by 2. ठीक है? Cos 45 is 1 by root 2. Uh-oh. So this is root 3 by 2 into root 2. Okay, root 3 by root 2. Option A आ गया है ना? So have you all answered this? Have you all answered this? बच्चा लोग? It's correct. You all have answered. Have you all answered the option A and still you didn't get the marks for Menti? That's what I'm asking. ठीक है. तो पता नहीं. The app says only 3 people have marked for the option A. हाँ, maybe something wrong है ना? पता नहीं. Okay, anyway. क्या कर सकता है हमको है ना? We can't do anything. Menti is like जो मैं करेगा आप लोग करना तो कर ले नहीं तो जाइए. So Menti is having that kind of attitude है ना? So we can't do anything. So anyway, hope the issue will be resolved for this particular question. Let's start. Fourth one. Okay, question from same part. Someone is asking me to give me these kind of questions, and almost same kind of question. Menti is senti like me today. Menti is आज थोड़ा attitude वाला Menti हो गया आज. पता नहीं, he is doing his own stuff. बच्चा लोग जल्दी. $18, $17, $16. Just like me, आप तो सेंटी नहीं है मेरा. Isn't it? Same here, son. I also don't like Menti today. Menti is like acting with full of attitude. Okay. So I hope this time everyone got your marks, right? 5 students got it correct. Okay. So the correct answer is option D. So whoever have marked, I hope you all got the marks, right? Okay, Amit again, the fastest. Then Mudila. Then Endado S. Aditya, Vishu, Zulu, proud. Thankama and Devapriya. Good, good. Clear? Okay. Now, देख लेंगे बच्चा लोग how to deal with this. देख लेंगे. The angle of dip at a place is 40.6 and the intensity of vertical component of magnetic field is 6 into 10 power minus 5 Tesla. So what is given? Vertical component of Earth's magnetic field is given as 6 into 10 power minus 5. How will you write vertical component of magnetic field? That is equal to B sine theta is 6 into 10 power minus 5. Okay. Yes. The total intensity of Earth's magnetic field at this particular places. Okay. Total intensity matlab ye B ka value. Okay. What is the value of theta given? Look at the question. It's 40.6. So that is equal to 6 into 10 power minus 5. है ना? ठीक है. Now, sine of 40.6. Now, just let us do the approximation because nobody knows the answer of what is sine 40.6. Sine 45 का value सबको पता है. कितना है? 1 by root 2. Right? So, B into 1 by root 2 is 6 into 10 power minus 5 approximation we are doing. So, B will be equal to 6 into root 2 is 1.4 into 10 power minus 5. So 6 into 1.4 कितना हो जाएगा? 1.4 into 6 कर ले 24 6 8. Okay, so we can say that it is 8.4 into 10 power minus 5. 8.4 into 10 power 5 is the answer once you take the angle as 45 degree. Okay, but now here it is sine 40.6. So B will be 6 into 10 power minus 5 by sine 40.6. Tell me, which one is greater? Is sine 45 greater or sine 40.6 greater? You know that as the angle becomes lesser, right, sine value also becomes lesser, right? Okay. So when you move from sine 45 to sine 40.6, the denominator becomes lesser. So the final answer will become larger than what we already have. So the larger value to 8.5, 8.4 here is only the option B, that is 9.2 to 10 power minus 5. We only did all these kind of approximation because we have no idea what is the real value of 40.6. That's it. Is it clear? Is it clear? So I hope you all have understood how we made this small approximations here, right? So that we can reach at the final answer, right? Sometimes when you deal with the questions, you'll also have to make these kind of approximations. So take this as a practice. Yes, clear? Okay, bilkul badhiya. So are we at the final question for today's session? Yes, here we are. Here we are at the very last question for today's class. So tell me, shall I press the enter? I think it's almost 11:40 na? So let me press. So I'm going to think that it's a yes from every one of you. Okay, last question thoda tough ho gaya. Anyway, I know that you all are going to do it. A current carrying coil is placed with its axis perpendicular to a north-south direction. Let horizontal component of Earth's magnetic field be H naught. Okay, and the magnetic field inside the loop is H. If a magnet is suspended inside the loop, it makes an angle with the H. I hope you understood. Last 4, 3, 2, and time is up. Let's see how many of you got this answer. Then I'll explain you how to do this problem. Okay, 4 students got it correct. बाप रे बच्चा लोग, बढ़िया. So Amit, proud of you, मेरा boy. Very good, Amit. Keep it up. Okay. Then we have Ndado Arire Adit, Mutila S. Thank you. Proud. Vishu, Zolu, Devapriya. Good, good. Awesome, बच्चा लोग. Awesome. So I hope you all have loved the session, enjoyed each and every concept that we have discussed, right? Okay, so shall we discuss how this particular question can be done? देख ले बच्चा. Let's say we have a ball which is having a charge q and kept in an external magnetic field in the direction of x-axis. Tell me what happens. Won't this be experiencing a force in the direction of electric field QE? And once this experiences an electric field in the x direction, what happens? You will see that it will rise up until it reaches an equilibrium position and it will stay here, right, with a force of QE, isn't it? आपको पता है ये. Similarly, what we have is we are having a magnet, right? So we are having a magnet, and let's say that this magnet is having a pole strength of M, and it is kept in a region where there is a horizontal component of Earth's magnetic field, which is given as H naught. So what will it be experiencing? Just like a charge will experience a force of Q into E, here this particular magnet with a pole strength of M kept in an external magnetic field will be experiencing a force. Here the force is charge into electric field, here it is pole strength into magnetic field. So what happens? It will rise up, rise up, rise up till it reaches some equilibrium position. In the equilibrium position, there is a force of M into H naught. There is a tension in the string. Okay, is it over? No, because they have specified one more magnetic field. Okay, and what is that magnetic field? It is a magnetic field produced by a current carrying coil. Arey sir, where is a coil here? There is a big coil here. That's what it is explained. So we have a big coil essay, and it is in this particular coil the entire setup is kept. Okay, so think that along the axis of the coil, okay, there is a magnetic field given, and it is given as how much? H. So tell me, if there is a magnetic field in the downward direction, which is H, will it be experiencing a force in that direction? Obviously, formula, it is equal to pole strength into magnetic field. So yes, so these are the three forces acting on this particular body. One is mh downward, mh not towards right, and t in this direction, in this random direction. So if I mark this particular angle as theta, we can express this tension as its components. ये theta, ये कितना हो जाएगा? ये theta हो जाएगा. Tell me, what is the component of t in this direction? T cos theta, isn't it? Yes. What about this component of t? T sin theta. Now what is left? As the body becomes equilibrium in that position, we can write the force towards right. That is T sin theta will be equal to the force towards left, mh naught. The force in the upward direction, that is T cos theta, will be equal to the force in the downward direction, mh. 1 and 2. We want to find theta. So we can avoid this unwanted tension from this particular t from this calculation. So divide 1 by 2. Tt ho jayega cancel. Sin by cos is tan theta is equal to h naught divided by h. Theta will be equal to tan inverse h naught by h. Okay. And there we have the answer. Okay, so our correct option is A. Okay, so our correct option is A, that is tan inverse H naught divided by H. So is it clear? Amit ja raha hai? Okay, so that was the very last question. So how was session for every one of you? Have you all enjoyed? And those who don't know, chalo. So on this particular Wednesday, 4:30 p.m., we have a special class. Don't forget. Do come on time. Those who haven't enrolled till now, jaldi enroll kar le. It's a complete chapter MCQ series, which means you'll get a chance to do multiple choice questions from all the chapters for term 1. This is your last chance because next week we won't be doing this kind of special classes. So this will be a great opportunity for you. So to do the questions from all the chapters all of a sudden, and you'll also get an idea how to solve questions when it pop-ups all of a sudden from all the chapters together. Okay, thank you Sanchana for those amazing words. Okay, bye Sudeep, I know that. So those who haven't enrolled till now, what do you have to do? You can just download an Academy learning app. Okay, go to menu section, type on special classes, then type in the code of AMD10. You can get into this class for free. It's completely free. Okay, Anna, thank you so much. So I'm so happy to hear a lot many sweet words from every one of you. So those who haven't liked the session, jaldi se jaldi enroll kar le. Okay, so yes, this is about Unacademy special class features. So thank you so much, everyone. I think everybody left, है ना? So what do you think about tomorrow at the same time? बिल्कुल में, because everybody left, I think. So tomorrow we'll start the class with a song. What do you all say? Now almost I am also half sleepy. You are also half sleepy, and मेरा गला भी half sleepy है. Okay, बिल्कुल. Tomorrow we'll start the class with a song. That'll be great. Okay, पक्का पक्का. मेरा promise है. Okay, so tomorrow I'll pakka sure say, because everybody already went, and then tomorrow everybody will be like sir again once again. Okay, so thank you so much for understanding, Anna. Tomorrow pakka. Tomorrow no excuse. Whatever happens, है ना? कुछ ना कुछ हो गया तो कल तो पक्का. Okay, it's a word from Ameer भैया. So मैं जा रहा हूँ, ठीक है? Thank you so much for your patience and being here with me and making the class so awesome and active. So bye everyone. Take care. Amit, Sudeep, Myara, Palak, Sana, Anna, Sanchana, everyone. Bye bye.